Hello everyone, welcome back to another video. My name's Beckwith. I'm an EEG technologist, and in today's video I'm talking about how I plan to integrate my EEG software into every single major EEG manufacturer. Now, how am I going to go about doing that? Pretty complicated, right? So first, how did I even get to this point? So if we go way back to 2019, before I even got into EEG, how did I even get into this? So before I was studying computer science, just looking up videos on YouTube and stuff, since that's what I'm naturally interested in, I found this professor at USF named Marvin, who was able to connect his brain to a drone and control the drone with his thoughts. And I was like, how is he controlling this drone with his thoughts? He was doing it with an EEG. He had artificial intelligence recognize the EEG signals that were when your brain thinks to move it up, down, left, right. I don't know exactly how it works, but that's what got me interested into EEG in the first place, connecting my brain to a machine or a computer. So that made me think in 2019, I need to study EEG, become a registered EEG technologist, and also that brought me to the concept of what I've been learning about previously on different YouTube videos, computer science algorithm called a convolutional neural network, which pretty much mimics the visual cortex, or the part that processes all the visual information that your eyes take in. It's in the back of your head and it's called the visual cortex. Now, the convolutional neural network mimics this. It mimics the simple and complex cells found in this area of your brain. So I initially had my heart set on using artificial intelligence. This is super advanced algorithm. This is what I was gonna do, and I was gonna do it to detect seizures. And once I was able to detect seizures, I was gonna go on to doing other crazier stuff like connecting my brains to computers. But detecting seizures is kind of like a gateway into more advanced computer science stuff that I could do with EEG. So with that goal in mind, I taught myself all about convolutional neural networks, and I actually made my own artificial visual cortexes. So this is probably late 2019 or early 2020, this was in 2020. So in 2020, I was able to build a artificial visual cortex that was able to tell the difference between different handwritten digits. So it may sound easy, but it's actually difficult because humans have all different types of ways of writing different digits. For example, you have the 4 like this, and you also have the 4 with kind of like a triangle. And also you have a 2 like this, and you have the 2 with the loop in the bottom. And then you have the 7 like this. Some people put like a line through their 7. All different types of ways of people writing numbers. Now, this convolutional neural network that I made is able to recognize whatever type of digit that you write. If humans write it that way, it's going to be able to recognize it. Now, I was able to do that with about 99% accuracy. Super excited about that. So then I moved on to building a convolutional neural network that can tell the difference between cats and dogs. So that was actually really cool. Cats and dogs, they're actually pretty similar, but since our human brains have been seeing cats and dogs for, since we were growing up, since a baby, it's super easy for us. But from a blank slate, a computer, it's actually very difficult. So the part that makes this difficult is that cats and dogs, they can be sitting in all different types of positions. Like a cat looking at you straight on looks a lot different than a cat curled up in a ball, or there's lots of different positions that the animals could be in, and the detector still has to be able to differentiate between this is a cat, this is a dog. It took some time, but with my brother and dad's help, I was able to pull it off and build a convolutional neural network that was able to tell the difference between cats and dogs. So the cats versus dogs and handwritten digits data sets were just practice for me getting to, in the future, abnormal EEG versus normal EEG, cat versus dog. And another one that we can do is ictal EEG, interictal EEG, and normal EEG. So the problem I ran into here was, while I was very good at using convolutional neural networks on image data, cats versus dogs, pictures of handwritten digits, there's not really much documentation on the internet about how to use a convolutional neural network on EEG data because it's such a niche thing. So I got stuck. I was frustrated. I didn't know what to do. Frustrated, I moved on to the next little project idea that I had, which was an eye open, eyes closed detector. So using the computer vision knowledge that I gained from the convolutional neural networks, I applied that to building a program that could detect eyes open versus eyes closed. Pretty cool, right? So it's super basic, doesn't work perfectly, but it actually worked, and it was really cool. And the people at my EEG lab thought it was cool as well. Now, I don't think it's very clinically significant. It's not as good as seizure detection. It's just eyes open, eyes closed. It's just a toy at the end of the day. So I made that, and then where did I go from there? Next up, I did chewing detection, and the reason for this is chewing creates a lot of distortion on the EEG record, and it's kind of rhythmic, so to an untrained eye, like a very new student, they might think it's a seizure. So we were able to label chewing, but it only worked when the patient would drastically, chew with their mouth open, like, and that's not gonna work. Nobody chews like that. I might chew like that sometimes if I'm alone and not using my table manners, but people normally do not chew like that. So that's a bust, didn't work out, so I moved on to the next thing. So the next thing applied to my brother's topology class. So he's going for his degree in computer science, he's in his last year, and one of his courses was topology, which is a math course. He's a very good mathematician, I would say, and for his final project, we did a analysis of EEG using a technique called persistent entropy. Now, you're not supposed to know what that means. I still don't even know what it means. So my brother wrote a whole report on it. Our findings were unsubstantial. I think a reason why is because he was feeding the data to the computer. It wasn't in a normal montage. I should have looked at it better. Maybe that's a reason why I didn't. And plus the study that we were trying to replicate, Piangerelli, he did it on pediatric EEGs, and I think we were doing it on adult EEGs. I still think we should pursue this further, but initially, with only like a week of work, no results, we didn't find anything. Discouraged again. What do? Persist. And I finally came down to this last idea, which is kind of like Siri, Alexa, or Google Home, only for EEG. I'm sure a lot of you guys have those types of systems in your home, but I have it for EEG now. So the reason why this hasn't been invented yet is because software developers, they're just in their own bubble, just coding up, being nerds. But me, I'm actually in the hospital doing this every single day, and that way I can have much better ideas on what to create in a clinical environment. Things that work in a research environment won't always work in a clinical environment, and this software that I made, it works in hospitals. So this works in the hospital, in the ICU, when you're doing activations or stimulating all the patient's limbs and doing passive eye opening. Very important. It's supposed to be done 2 times a day, at least in our hospital, but it almost never is done that many times. So I found a way to make it a lot more efficient. Now it's kind of a secret at this point. I'm super excited because I finally found a software that I think is clinically relevant, meaning I would use it myself. Now that I have a working prototype, I have to integrate my software into all the different major EEG manufacturers like Neon Coden, XLTech, Natus, Compumedics. So I was talking to my good friend Tara about how I should move forward. She said if I'm not looking to sell the software, I have to come to a corporate agreement with all these different big software companies, and that would allow me to integrate my software into their software. Since I don't think I'm trying to make my own EEG acquisition software, I'm more interested in the little applications like automatic seizure detection, this ICU activations assistant, stuff like that. So since that's what I'm interested in, it would make sense for me to partner with these different software companies and integrate my software into theirs. So the next steps for me forward are to test this software myself, make sure it's good, make sure it's something that other people can use, because in its current form I could use it, but other people couldn't. It has too many bugs, let's just say that. But I would be able to use it and test it myself until it gets better. I have the engineers working on it, making changes as we speak, so it should be improving enough to be able to be used in a clinical environment. So I'm super excited about that. Just once it's ready, I'm gonna have to reach out to all these different software companies. I have people on LinkedIn who connected with me from all these different companies already, so I kind of already have a connection. So that's good. I'm already halfway there, right? So if you work at any of these companies and you want to see my software integrated with your platform, if you want to test it out and try it, be a beta tester, let me know. I'm happy to connect with all you guys. We have such a small field here in EEG. If you're in the same field as me, I'd love to be your friend. Reach out to me in the direct messages. I'll give you my phone number and I'd love to talk. So thank you all for watching. I will see you guys on the next video. Make sure you hit the like button too.